All right, guys, so today we're going to continue with our inequality business today. But first we're going to do something that we're a little more familiar with. Let's take a look at our question. It says you are very hungry, so you go to a fast food restaurant. You have exactly $15.02. You love big burgers and cheeseburgers. Based on past experience, you know you can only eat 7 sandwiches. Big burgers cost $3.70, while cheeseburgers cost just 98 cents. How many big burgers and how many cheeseburgers can you buy? And we're just disregarding sales tax, things like that, already figured in there, okay? All right, so number 1 says write a system of, and I wanted to make sure we're bringing this element back in too, because we're probably not going to see it again. Something we're already familiar with. It says write a system of, whoa, that's really thick. Whoops. Write a system of equations. Write a system of equations. So I know we've been working with inequalities. So what's the difference? If I ask you to write an equation versus an inequality, what's the difference? Equations have just equal signs. That's all we get. Inequalities are our less than, greater than, less than or equal to, greater than or equal to. All right, so I even went ahead, I put the variables on there for you. Said let B represent the number of big burgers and C represent the number of cheeseburgers. Take a minute here, see if you can write the system. So 2 equations, system of equations, so 2 equations, and they're going to have equal signs. So take a read through, pick out your key pieces, B for big burgers and C for cheeseburgers. See if you can set it up. All right, so as I walked around, some of you are already finished, and some of you are just sitting there like, okay, Miss Scott, I'm just going to wait for you to write it up there so I can write it down. About a week ago, you guys all rocked at setting this type of system up. We talked about looking for totals when we set these up. I know I have $15.02. I know that's one of the totals that I have. Now that's a dollar amount. So if I have a total that's a dollar amount, I have to bring in the cost of each type of burger. So my big burgers are $3.70. So $3.70 for each big burger. And then we had 98 cents. 98 cents for each cheeseburger. A lot of you had that equation when I walked around. The money equation we're usually really good at. It's the other one we get stuck with sometimes. This was the one type of equation that we got kind of stuck with in that last unit. We know our other total is we can only eat 7 burgers, but then that's where we get a little stuck. And that's where defining our variables comes in handy. It says, let B represent the number of big burgers. C is the number of cheeseburgers. So if I take the number of big burgers plus the number of cheeseburgers, it's going to equal 7. You're going to eat 7 sandwiches. So that's why defining our variables is so important, so we know what each one means. It makes writing those equations a lot easier. If I just put B as big burgers, I don't know if that means I'm looking for the cost of one, how many I have. I'm not sure. So these are very specifically labeled for you. B is how many. It's the number of big burgers. C is the number of cheeseburgers. Number 2 says we want to graph this system. So I gave you, if you go to the other sheet I gave you, I couldn't fit the graph on here unless I put it on the back. And I didn't want you guys flipping back and forth. So if you go to the other sheet I gave you, there's a pretty giant graph up at the top. I wanted to make sure we could see things very well on this. So have it looking like this side. Should have the name at the top. Say Systems of Linear Inequalities, Day 1 up at the top. And we want a graph. Now since this is an application, our variables mean things. Let's have our big burgers. Let's have our big burgers be on the x-axis. All right, big burgers on the x-axis. And let's go cheeseburgers on the y. It doesn't matter which way you want to do this. This is the way I'm going with. We don't have an x and y, we have a b and a c. So I'm going to choose big burgers to be our x and our cheeseburgers to be our y. No big deal. Either way. And we're just going to have our scale go by ones. Just have our scale go by ones. And so our first equation, I'm going to go ahead and just jot that over here. 370b plus 98c is our $15.02. What form do we have? Do we have slope-intercept or do we have standard? We have standard. Our variables are on the same side. It's not an x and y. If you want to change it to an x and y to graph, you can. But we have our b and c on the same side. If you need to change them to x and y to graph, you sure can. So when we have our standard form, that means we want to graph with our intercepts. And we've been working a lot with the application ones that the intercepts haven't worked out to be pretty. We've had a lot of decimal intercepts, and that's absolutely fine. That's okay. We've graphed a lot of decimals with our application, with our inequalities, and they worked out just fine. So we can do the same here. So if I put a 0 in for my b, what's going to happen to my term with b? What's that going to equal if I put a 0 in for b? It's going to be 0. So I'm going to go ahead, I'm just going to try to save some space here. So we have 98 cents times our c. Alright, so then we divide by our 98 cents. I know it's not going to work out pretty. Let me grab my calculator here. What do we got? 15.32 something, so we're going to go 15.3. So I put a 0 in for b, so that 370b, that's gone. Became a 0. So I'm just saving myself some space. If you want to write it out putting the b in, or the 0 in for b, you can. Alright, then we put a 0 in for c. So that means my term with the c is going to be a big old 0. So I'm going to be left with 370b equals 1502. Divide by your 370. And we get it's going to be about 4.1-ish. We're going to go ahead and just round. 4.1-ish. Not the prettiest of intercepts. Not the prettiest, but that's okay. We've been working a lot with decimals when we did our application and with our inequalities so far. And decimals are okay. We can graph them. It's just a sketch. We're okay. All right, so I go to my little table, and we see that cheeseburgers is at 15.3. Cheeseburgers we chose to put on the y-axis. So let's go 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then 0.3-ish. Now again, you just have to do your best, because I know by the time you draw your dot in there, sometimes the boxes are so small that it takes up most of it anyway. And then our big burgers are on the x-axis, and they were roughly 4.1. 1, 2, 3, 4.1-ish right there. Oh, go a little bit closer. There we go, if we can. There we go. Then we have to graph our other one. These are going to work out much, much, much better for us. These are going to work out much better for us. We have b plus c equals 7. Do I really need to do a lot of work here?
No.
What's c going to be if I put a 0 in for b? 7. What's b going to be if I put a 0 in for c? 7. They're both going to be 7. But let's go ahead. Let's use our other color. I'm going to go ahead and connect these two as best as I can. I don't have much of a straight edge here. And then I'm going to grab my other color to graph my second line. So I'm going to grab kind of this bluish color here. bluish blackish, so I can kind of match you. You guys have red and then a pencil or pen. So we've got 7 and 7. 1, 2, 3, 4, 5, 6. There's 7. 1, 2, 3, 4, 5, 6, 7. And again, I know I don't draw the straightest lines up here. I can't put a straight edge on mine up here, so we're pretty close. You guys can use a straight edge on yours. So our solution, we want to know how many of each type can we buy. Now it's such a small number with 7, yeah, we probably could have done some guessing and checking, but that would take us longer than graphing. I'm hoping at this point we've gotten pretty good with standard form. That should be pretty quick for us. So then what's my solution? Where do I find how many big burgers and cheeseburgers I can buy? Where they intersect. So it looks like, what do we got there? 3, 4?
Yeah.
Should be at 3, 4. 4, 4 would give us 8 burgers. We want a total of 7. It's at 3, 4.
Yeah.
And I know it can be, I know we just did a sketch. We've got some intercepts that are decimals. So it should be at 3, 4. Should be at 3, 4. So on our other sheet, I'm just going to pop back. And we should have 3 big burgers we can buy and 4 cheeseburgers we can buy. All right, so now it says, step number 4. It says, now suppose you decide you don't want to spend all your money, and you also realize that you would be fine to eat fewer than 7 sandwiches. That's a lot of sandwiches. I don't think I could put 7 cheeseburgers away on my best day. So what we want to do, we don't want to spend all of our money, and we don't want to eat 7 sandwiches. So we're going to change our system of equations with the equal signs to a system of inequalities. So when we see inequalities, now we're switching gears and we're thinking of greater thans and less thans and greater than or equal to, less than or equal to. So if we take our money situation, so 3.70B plus 98 cents C, and we have $15.02. It says we don't want to spend all of our money. So which way is my symbol going to open? Towards our B's and C's or towards my 15.2? To my 15.2, because 15.2 is the most that I want to spend. So remember we did some application last week with inequalities, and we talked about not getting hung up on, are we going to do less than, greater than? Because really, a less than or greater than depends which way you have your inequality arranged. I have a less than right now, but if I flip-flop sides, if I put my 15.02 over on the left side, now a greater than makes sense. So I'm not so much concerned with, is it going to be a less than, is it going to be a greater than, as which way should it open? 15.02, that $15.02, that's the most I want to spend. That's the most. So we want our symbol to open towards that 15.02. Now it says we don't want to spend all of our money. So do we want an equal to? No, because we don't want to spend it all. Then our sandwich question. It says you'd be fine if you ate fewer than 7 sandwiches. So are we going to open towards the B's and C's or open towards the 7? Towards the 7. Because the 7 is the most I want to go. And does it say we still want to eat 7 sandwiches? No, we want to be fewer. So we're going to leave that equal to off there. Now it says graph this system of inequalities. Here's the great part. Let's go back to the graph we just did. Here's the great part. We already have the boundary lines graphed. We already have the boundary lines graphed. we need to test and shade. But now the boundary line piece, though, do we want them to be solid? Are our boundary lines going to be dotted or solid? What do you think?
Dotted.
Dotted, because
it's
not equal to. So we're going to have a less than there and a less than here. And then just take your eraser. Oh, mine's not going to let me do little chunks. But you can just take your eraser and erase just little chunks. I can't do that on mine. I wish I could. Thought maybe I could, but it just takes my whole line. And just erase little chunks of yours, and we're good. Just erase little chunks. We just want dotted lines. We don't have to go through all the work to regraph them. Just take little chunks out. So now here's a great refresher for some of us. Some of us on our quiz on Friday, and we're going to get those back. Some of us on our quiz last class, we kept shading the wrong way. So here's a great refresher on us. How do I decide which way to shade? Easiest point in the world to test is 0, 0. 0, 0. Here's where it's at on my graph. And let's go ahead and test 0, 0. I'm going to test it in my first one that I have graphed in red. So if I put a 0 in for both of my variables, if I put a 0 in for both my variables, what's this entire left side going to equal? A 0. Is 0 less than 15.02? Yes, that's true. So where do I shade? The bottom side, where 0, 0 is. And I would keep your shading, guys, since we're going to be graphing both of these, keep your shading nice and light, or draw lines like I did. Don't shade super dark, because we have to shade our second one yet, too. We have to shade our second one yet, too, so don't get too dark on your shading. Testing 0, 0 on the second one, that's really easy. Is 0 less than 7? Yes, it is. So we again shade. We again shade where 0, 0 is. Some of you were testing 0, 0 on your quiz, and you found it to be true, and then you shaded the opposite way. We want to shade solutions, which means we want to shade ordered pairs that make that inequality true. So now if you look at your hamburger sheet, if you look at number 6, it says how many different sandwich combinations can you buy to fulfill your new criteria? It says to complete the chart at the right. Now you don't have to do a lot of work. Don't bother like trying to substitute in and all those kinds of things. Let's take a look at our graph. We shade solutions. We shade solutions. So my question to you is, where are the solutions or the ordered pairs that will make both of our inequalities true? Where's that area at on my graph? What do you guys think? The shaded area. More specifically, where at in my shaded areas? Where they do what? Yeah, where our shadings intersect. So kind of this little pocket right in here. Take a look. It's where the blue that I have overlaps my red. Or where your pencil and your red pencil overlap. Or your pencil and your pen, whatever you have. Where your two colors overlap. Those are the shadings that make both of my inequalities true. If you have ordered pairs that make both inequalities true, those are solutions to the whole system. If you have ordered pairs that make both inequalities true, those are solutions to the whole system, if they make both true. So if we're wondering what some solutions are for our big burgers, you already have filled in 0 burgers. Oh, let me switch back here. On your chart, you have 0 burgers and 1 cheeseburger filled in. In your chart, you have 0 burgers, big burgers, and 2 cheeseburgers filled in. Any ordered pair that is shaded is a solution. So then we have 0 big burgers and 3 cheeseburgers. So that's the next one on your chart. 0 big burgers and 3 cheeseburgers. Then we have 0 big burgers, 4 cheeseburgers. 0 big burgers, 5 cheeseburgers. 0 big burgers, 6 cheeseburgers. So now, though, the question is, there's one more 0 on your chart. There's one more 0 on your chart. Can I fill it in with 0.7? No, because 0.7 is on our dotted line. There's no equal to. So you guys have that last 0 on your chart. 0.7 doesn't work because it ends up on the dotted line. 0.7 doesn't work because it ends up on the dotted line. So what I have highlighted on my graph, you should have this filled in on your chart. These are the ordered pairs right now that I have highlighted on my graph. I can't have both screens up at once. These are the ordered pairs I've highlighted on my graph. They are in our solution region. So now the next part on our chart, it says we have 1 big burger and 0 cheeseburgers. 1 big burger, 1 cheeseburger, the ordered pair 1, 1. 1 big burger, 2 cheeseburgers. 1 big burger, 3 cheese. 1 big, 4 cheese. 1 big, 5 cheese. 1 big, and 6 cheese is okay because it's below our line. It's below our line, it's in our shaded. So on your chart, you should have all the 1s filled in. So on your chart, just want to make sure we're making the connection. 0, 1, 2, 3, 4, 5, 6. All of these are ordered pairs. These are all ordered pairs in that bright yellow solution region on my graph. So take a minute, see if you can fill in the rest of the chart. All right, so when we move on, all right, so if we go to 2 big burgers, we can do 0 cheese, 2 big and 1 cheese, 2 big, 3 cheese, 4 cheese, 5 cheese. Can I do 2, 6, or does that end up on my line? What do we think? 1, 2, then I go 2, 0, 1, 2, 3, 4, 5, but then 2, 6. 2, 6 is on my line. If my line were drawn straight, 2, 6 would be on my line. Since 2, 6 is on my line, I can't put it in my chart. I can't do 2, 6. It's on my line. Then I move on to 3 big burgers. 3, 0 works. 3, 1 works. Can't see my graph at the same time. Here we go. 3, 1 works. 3, 2, and 3, 3. Those all work. And then I move on and I have 4. Does anything with 4 work? 1, 2, 3, 4, 0 should work. And that's all I can really do with the 4s if I pop back. 1, 2, 3. Here's my 4, 0. 4, 1, if my line were straight, 4, 1 would not fit. If my line were straight. My line's not the straightest. I can't do that up here. 4, 1 wouldn't fit. So what you have on your chart, I want to make sure we're making the connection, because some of us, based on our quiz, we kind of missed the boat a little bit on the application piece and where I find solutions. I find solutions in the shaded region. I find solutions in the shaded region. Any ordered pair, so I have most of them highlighted for you. Any ordered pair in that shaded region, any ordered pair in that shaded region will make both of my inequalities true. I just have to put the labels on them. So instead of just X's and Y's, if I go back to my chart, I have big burgers and I have cheeseburgers. Any ordered pair in the shaded will be a solution. It's a combination of how many different possible sandwich combinations I could have. How many cheeseburgers, how many big burgers. Those are all the possible ones that I can have. Okay, so let's take that, and we will do more application type stuff, but I want to focus on first just the plain old systems. We will get to the application piece a little more. I wanted to use the application to help you see a little review on equations, systems of equations, and then introduce us to our systems of inequalities. So systems of inequalities, we have 2 inequalities. Just like a system of equations, we had 2 equations. Now we have 2 inequalities. So let's go ahead and let's graph both of these one at a time using your 2 different colors. So I'm going to go ahead, I'm going to start with kind of my darker color. Let's graph our first one. Y is greater than or equal to 3x minus 4. What form do we have? Slope-intercept. So 3 is my slope. And I know a lot of you, as soon as you pick it out, you put it over 1. We could go up and right.
Or down and left.
Or we could go down and left. And then our y-intercept is -4. Dotted or solid line before we even graph any points?
Solid.
Solid, because I have the equal to. So I'm going to put a little solid note next to this one. Notice how I pulled those apart. Just like when we were doing systems of equations. I like to pull them apart. Take a look at them separately. So my y-intercept's at -4. 1, 2, 3, 4. My slope of 3. We could go up 3. 1, 2, 3, and right 1. Or we could go down 3 and left 1. We said solid line, so I'm going to do my best to draw that in here. You guys can use your straight edges. We said it was going to be solid. Let's go ahead and test. This is a nice review for us. If you were kind of shaky on this on your quiz, the quiz was graphing just single inequalities, not systems. The quiz was graphing single ones. So if you're a little shaky on which way to shade, this is a great review opportunity for you. Test 0, 0, which means, guys, I don't rewrite anything. I don't move where anything is at in that inequality. I put a 0 for the x, I put a 0 for the y. I don't change the inequality symbol. I don't change where the -4 is. I don't change where the 3 is. We end up with, is 0 greater than or equal to, we get 0 minus 4. Is 0 greater than or equal to -4? Yes, it is. 0 is bigger than -4, so I'm going to shade the side of the line that has 0, 0. I'm going to shade the side of the line that has 0, 0 because it made my inequality true. So last week, this was our focus. Last week, I would have given you just this single inequality and asked you to graph it. Now we're upping our game. Now we have a system. Now we have 2 to worry about. So I'm going to grab a different color. I'm going to grab red because that's what most of you have for your second color. And let's go y is less than negative x plus 2. That's our second one. I want to pick it apart just like I did the first one. Most of you on your quiz, you rocked at graphing the single inequalities. So now we're just upping our game a little bit and we're graphing 2 on one graph. If we can graph 1 on one graph, we can sure as heck graph 2 on one graph. Let's pick it apart. I chose this inequality just for what its slope is. I had a lot of questions on this when we were refreshing on graphing last week. What number is really in front of that x?
1.
What kind of 1? Yeah. Slope is negative 1. Put it over 1. So we could go down and right. I'm going to try to squeeze this, or we can go up and left. Yep, try to squeeze that in there. There we go. And then our y-intercept is positive 2. I had some of you a little shaky on that last week if there wasn't an actual number written in front of x. Some of you are like, wait, Miss Golly, what's my slope? So I wanted to make sure we hit on one of those today together. So y-intercept of 2. And we could go down and right. Or we could go up and left. And we get the idea. Ooh, dotted or solid? I forgot that.
Dotted.
Dotted. There's no equal to. So we go dotted. Here we go. There we go. Kind of going through those points. Now, if we just had equal signs, we'd be trying to figure out where those 2 lines intersect. I don't care where those 2 intersect. We don't have to try to rack our brain and figure out what that not fantastic working out point is. I want to shade with my other line. I'm going to test 0, 0 because that's the easiest point in the world to test unless my line goes through it. Is 0 less than negative 0 plus 2? I changed nothing else. Some of you, when you were testing ordered pairs on your quiz, you were rearranging some things and your less thans became greater thans, and I'm not sure what was going on. So we end up with, is 0 less than 2?
Yes.
Yes, that's a true. So we're going to shade the side with 0, 0. So far, nothing new from what we were working on all last week. Draw our boundary line, test a point, shade. Instead of 1 inequality on our graph, we now have 2. But now we're concerned with where are all the ordered pairs that will make both of these true. The shading we did with the kind of the navy-ish color, or probably your pencil or your pen, the first shading we did would make all of the first inequality true. All the shading in the red will make the second inequality true. So where do I shade that will make both of them true? Where my shadings do what?
They cross?
Yeah, where my shadings cross. Up here I kind of drew straight lines, so it almost looks like where there's kind of a checkered pattern there, where they kind of overlap. Where your 2 shadings overlap, that's why I wanted you to have 2 different colors today. Where your 2 shadings overlap, that's where all the ordered pairs are that are going to make the whole system true. Just like when we had our systems of equations last unit, we needed an ordered pair that would make both equations true. Now I need ordered pairs that will make both of those true. So for my first inequality, that was kind of my bluish color up here, anything shaded blue, any ordered pair shaded blue would make the top one true. Any ordered pair shaded red will make the second one true. So the ordered pairs that will make both true are where my red and blue overlap, where I have it highlighted bright yellow now. Okay, so we're taking what we did last week, we're taking two of them from last week and putting them on one graph. That's the idea. So below this, though, it says we want to find two actual solutions. I want to make sure we stay fresh on this, where the solutions actually are. So the solutions are anything in that bright yellow piece. So I'm going to go ahead and grab, let's see, let's go, I'm going to go negative 1, 1. Negative 1, 1. I just highlighted that ordered pair in red. Negative 1, 1. It's in my bright yellow region, so it should make both of these true. It should make both of them true if I've shaded right. So I'm going to grab that top inequality. Instead of y, I'm going to put 1. Instead of x, I'm going to put negative 1. Do a little simplifying. I get a random screen. I get negative 3 minus 4. 1 is greater than or equal to negative 7. That checks. Second inequality, I put a 1 for y. I put a negative 1 for x. The x is already negative, so when I put a negative 1 in, yes, I need both of those negative signs. And it does become positive 1. Is 1 less than 4? Yes, it is. Any ordered pair in that yellow shaded region should make both inequalities true. That's how I know I shaded right. Let's just test a second one. I want to make sure we're okay with that part. Again, for some of you, when we did the application part on the single inequalities last week, you kind of missed out on the question where it was, what are the solutions? Give me one solution. We weren't sure where to find those. So I want to make sure I'm really hitting home today. The shaded is where we find the solutions. Any ordered pair. So let's go, let's see, 1, 2. Let's go negative 3. Let's just go negative 3, 0 right there. Let's make it easy. Let's put a 0 in there. So again, I'm choosing negative 3, 0. It's right here in the yellow. You can pick any ordered pair you want. So don't get too hung up on Miss Holly, but how did you know to pick negative 3, 0? Why did you pick that one? Because it's in the yellow. You can pick whatever you want. So go ahead, let's take a minute here and test it out. So wherever you see x, you're going to put negative 3. Wherever you see y, you're going to put 0. So I have 0 greater than or equal to 3 times negative 3 minus 4. 0 is greater than or equal to negative 9 minus 4. 0 is greater than or equal to negative 13. Yes, it is. Is 0 less than? Again, we have that negative, negative. Negative, negative becomes positive. 0 is less than 5. And I know we can all substitute in for x and y. I'm not doubting that part at all. Not at all. So go ahead, flip your sheet over. Whoops. So go ahead and flip your sheet over. And go ahead and graph that system. If you need to, just graph one at a time. I'm going to switch back to my darker color. You've got x minus y is greater than 2. Just graph that one. In just a minute, I'll put up what it should be so you can check yours before you move on to the second one. Just make sure, shade real light, draw things real light, just in case. I mean, if you do make a mistake, you can always erase it. It's not a big deal. So when I look at this, the first thing I'm going to do is I'm going to notice it's a dotted line. Then I'm also going to notice x and y are on the same side, so I'm going to say that I have standard form. If I have standard form, that's like our burger example today. I want to put my zeros in. You have to be careful. When you put 0 in for x on this one, though, you actually have negative y equals 2. So you do have to divide by negative 1. Then when you put 0 in for y, your x is just 2. So negative 2, x is 2. So double check your line. Double check your line. And then it should be dotted. And then go ahead and test. So you do have standard form. Be careful though, when you put a 0 in for x, it's really a negative y you have left. And then when you test, you get 0 minus 0 is greater than 2. Is 0 greater than 2? No. So I need to shade away from 0, 0. I need to shade away from 0, 0. 0 is not greater than 2. So 0, 0, it didn't work. I think for some of us, when I saw quizzes, some of you just automatically shaded where 0, 0 was. You've got to test it out first. We only want to shade solutions. Solutions make our inequality true, not false. Our second one, we again have x and y same side. We again have standard form. And we again have a negative sign in front of our y. So when I put 0 in for x, we get negative y equals negative 3. Y equals 3. This is one of the big reasons why I chose this example. For a lot of you on your quizzes, you did a great job with standard form, but sometimes we forgot negative signs in front of our y when they were really there. And this one I forgot at the beginning, it should be a solid line. It should be a solid line. Excuse me, solid, I just drew data. Jeepers, here we go. Fill her in. I said solid, and then I drew dotted. There we go, fixed her. Test. 0, 0. So 0 minus 0 less than or equal to negative 3. Is 0 less than or equal to negative 3? No, it's not. Sometimes, just like we saw with our systems of equations, sometimes they didn't work out. Just like when we just had our systems of equations with the equal signs, like we had very first today to start, we were looking for an ordered pair to make both of those equations true. We were looking for the two lines to intersect. With inequalities, I'm looking for the two shadings to intersect. So when we had just equal signs, we're trying to figure out where the two lines intersected. Now that we have inequalities, we're trying to figure out where the two shadings intersect.
They don't.
My shadings don't intersect. So if the shadings don't intersect, there's no solution. So when we had our systems of equations with the equal signs, we were looking for the two lines to intersect. Now that we have inequalities and we're shading, we're not so much looking for the lines to intersect, we're looking for the shadings to intersect. Where the two shadings intersect, that's where all of my solutions are. Any ordered pair where the shadings intersect are my solutions. Any ordered pair where the shadings intersect, those are my solutions.